Good afternoon, everybody, and thank you for joining our event today with the LJC. For those of you who don't know, my name is Abby and I work with Barry Cranford, who's the founder of the LJC, and I have the privilege of hosting today's event for you. If you didn't know, the LJC stands for the London Java community. It's just one of the communities run by RecWorks. We are a tech recruitment company with a massive difference. As a company, we believe that recruitment really can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development. From our perspective, if people want to learn and others want to teach, we are happy to connect those people through our communities and events. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. To date, we have run over 700 events for engineers and developers, students, graduates, CTOs. We have run conferences, lightning talks, hackathons, mingles, all sorts. In January, we made our 4,000th introduction through our Meet a Mentor program, and we're really excited to see where that's going to go next. As I've already said, we love to give opportunities for people to connect, and this event is part of that. If you would like to know more about any of our communities, please do get in touch with Barry or myself, and we can take it from there. The recording of today's session will be available on YouTube. If you search for RecWorks, you'll find it there, or just contact me on LinkedIn and I'll be able to send it to you. I'll put my LinkedIn profile in the chat for you. Fabio is going to be speaking to us today about how to make your environment sane with Ansible automation. If you have any questions as we go along, do feel free to put them in the chat and we'll be able to take them from there. And over to you, Fabio.
Thank you, Abby. So I'll be sharing my slides.
I can't hear you, Fabio. You just go on mute.
Okay, sorry. Do you hear me now?
Yeah, perfect.
Sorry, my slides got my mic. So a little bit about how I ended up with Ansible. And this is a nice story. This is back in 2015, so 7 years ago, 2014 maybe even. And I went to this company and I was a freelance consultant. And they had something like 300 Glassfish installations in a mix of versions from 4.0 to 4.1.1 with kind of the same application running on it, but it was not really exactly the same application because they had different version running of it, different builds, whatever that meant for them. And those were mainly running on EC2 instances. It was weird because they started with bare metal servers. In fact, they still had around 50 of them. And then they moved to create new instances for new customers on AWS because it was cheaper for them. But when they did it, they kept exactly the same idea of installation that they had on bare metal, but just applied on cloud. So effectively, they ended up with having up to 10 different Glassfish installation on the same machine, and also 10 different MySQL installations, because that was an application that was running MySQL. So they ended up with this very messy situation. And due to the fact that they used to have 5 scripts per instance to do like basic restart, start, stop, restart, and deployments, they also had 1,500 scripts scattered around, those servers. And even the servers themselves, Linux were different version, a little bit of a mess. So the question that I was, why was I there? So I've started many years ago as a consultant and as a freelance consultant, and have been for the majority of my time an infrastructure consultant, so mainly around Linux and then automation and cloud as well. And 7 years ago, when this happened, I also started to work with Ansible. And from there, I have always continued with Ansible to the point that I've now have more than 150 contributions to the Ansible core and wrote 3 books on that. Now I do work as a senior solution architect for GSI partners within Red Hat. So how did we, what was my view of the situation was that to solve it, we needed an automation system, some kind of automation system. At the time, there were some that were more common than Ansible. Those were Chef, for instance, or Puppet. But I was not very happy with them, and the customer was neither. And we created this list of things that we were actually looking for in an automation system that was sensible for us. So the first step was that it needed to be simple, because if you have a complex system, then you add even more complexity to an environment that, as you have seen, was already fairly complex. So it made no sense to add even more complexity to such an environment. The second part was that the rollout of this automation system would have happened over the course of many months or years eventually. And therefore, we could not have 2 different environments that were completely different, one with automation and one without automation. And the automation system should have been able to, in one hand, help us on new environments to make them clean, but also to manage the old environment as well. So, for instance, there are some automation systems that need or require or really like to be the only service that is changing files on the system, or daemons, or are very pervasive. We did not were looking for that kind of thing. Also, this environment was handling PCI DSS information, so effectively credit card numbers, and therefore adding something such as a daemon to every machine would have changed completely the security model of the environment, and therefore it would have been even more complex to do such a thing. Also, we were looking, for the same reason, to something that was kind of self-documenting, because the idea was that after we created new environments completely with this tool, we could somehow create documentation on what exactly were the configuration of those environments, who had access to what, and the other things that auditors like to see, in a way that was very quick. So it could either be, let's print the code and give it to them if it was clear enough, or at least we start from the code, but quickly we can move to a documentation that is available or can be made available to auditors. And then we had this thing about idempotency. And when I started to create the list, that was not part of it. I've added it after a while of research on Google and the other engines because I discovered the importance of this. So what exactly is idempotence? Idempotence is the property of certain operations that basically allows you to apply them multiple times or execute them multiple times, but only change the result the first time. So effectively, example of this is x equal 100. Now, if x was equal to 10, the first time it will change from 10 to 100. But from the second time you apply this to the same x value, then you will always get 100. So only the first time you have a change. Same thing for x equal x at the power of 0. First time, no matter x, the result will be 1, and then from that point on, it will always be 1. Another example, a little bit more computing example, is echo test to root example, and this will replace completely the document. Therefore, the first time example will be created or changed to contain test, and then from that point onward, it will be always the same. So by contrast, 2 examples of something that are not idempotent is x equal x multiplied by 2, because every time x will be increasing. And the second example is very similar to the previous idempotent one, but has 2 angular parentheses, which means that the test string only gets appended to the file. So effectively, what we will get is every time we execute this command, the file will be 1 line longer. Now, there are some aspects, some operations in IT, which is not that clear if they are idempotent or not. It depends on what you define in your environment as idempotency. And the reason why I'm mentioning those is because sometimes it's white or black, but a lot of other times is in a scale of gray. So for instance, YAM update or APT update or whatever you use is not really idempotent in the strict sense, because at the end of the day, if you run it today or tomorrow, you will get different updates from the upstream repository, because effectively the packages in the upstream repository will change over time. Same thing is for YAM install. Now, there are some distribution that allows you to pass the specific version of the package that you're looking for. And in theory, that should be idempotent. But if you only do YAM install or APT install, then you might get different results when you apply it at different times. The same applies for wget, because if you wget to a server that is controlled by someone else, obviously you have the risk that someone else will change the file, and therefore your operation will be different at a certain point in time. Or you could have a problem like internet downtime or a server downtime in the server side, and the result would be that command would actually fail, and if you don't handle correctly the failure of it, obviously it will be could be catastrophic at least. And I would like also to point out another example, which is very similar to the previous idempotent one, but by printing a variable. $x is a variable in bash. So effectively, this is not a guaranteed idempotent operation, because $x could be changing over time. And I have seen an example in a customer where they executed a command, MySQL command, to a server to get information out of one of the fields of a table, and then put that information in a variable, and then executed a bunch of stuff in a variable. One night, the database server was not online because it was doing some backup, and the field was empty. I mean, the server did not reply, and therefore the variable got set to empty, with the result that they blew up a server, basically, because they were operating like rm-rf and then variable /*. So those could be fairly dangerous situations, but you need to think about what level of idempotency you really need or want. So we found Ansible as the solution to all those issues or requirements that we had. So first of all, Ansible is agentless, even though it's now possible to run it agentful with various open source implementation of server kind of server for Ansible, or process for Ansible, it's when we are talking about Ansible, it is to be considered agentless by default. It connects to machines via SSH. Here also now there are some other protocols available, but I would say SSH is still by far the most used one. Therefore, it's very similar to the previous model where security model where the user or the administrator would connect to the machine via SSH and then execute command from there. It does not really care about the state of the system because it has a list of changes or state to obtain, and then it will work through them in a sequential way, which makes the whole writing code for Ansible and then debugging it eventually very easy, because it's like step by step, very linear and so on. There are other solutions that tend to go to parallelize the executions to obviously minimize time, but that creates complexity because obviously you need to write some parts that are not dependent one on the other, or put all the requirement of dependencies. Otherwise, obviously, you might encounter issues there. And then when you find yourself to debug them, it becomes more complex. Also, due to those reasons, it has a very gentle learning curve. We will see a little bit of Ansible code, playbook code, in the following slides, but you will see that it's fairly easy to read. And this is also very important because while it might be a little bit complex to write, if you don't know exactly the parameters and how to write stuff, it's very easy to read. So effectively, even non-technical people, such what auditors could be or other people in the business could be, can read fairly easily Ansible playbooks. It's also very simple to set up, as we will see, and it's a tool that is very flexible. You can do configuration management, deployments, orchestration, or automation of pretty much any kind that you can think of. So how you can start with Ansible, and this is how we started. So we created an SSH key because obviously we want to have an SSH key pair that was exactly for Ansible. It was its own. We did not want it to have the administrators sharing their credentials with Ansible. You need to distribute that SSH key in whatever way you currently do it, and then create a Git repo for the Ansible code so that you also have the whole history and you can go back and see what exactly was the code in a certain moment in time, and also who did which change. And then you can start to create an inventory, which is basically a list of hosts. And then from there, you can start to execute stuff. So the first thing that we asked ourselves is, now what? We have this tool that is pretty much ready. What should we now automate? And we thought about, let's start from something that is easy. This is the first time that we are using Ansible, so let's start from something that is non-critical operation. So even if we take more time, or something goes wrong or whatever, the business is not impacted. Second, it needs to be a very well understood operation, at least by someone in the team, and then it's an operation that is fairly easy to test, which allows you to say, okay, the operation or the playbook was correct, or let's fix it here and then rerun it, and then hopefully it works better this time. So what we opted for was the deployment of a new server. Now, even if one of the initial requirements was to be able to run it on the current environment, we decided to do exactly the opposite in reality. So we decided to create a new server, install Java, create the Glassfish user, install unzip, the utility unzip, and then download Pajara, unarchive, and then set ownership and create systemd unit. Why am I saying that this was different? Because differently from the previous servers that were created before, we decided to use, first of all, Pajara instead of Glassfish, which was very similar but fixed a couple of bugs that they were encountering. But also to move from the idea of one installation per instance to one domain per instance, and therefore only one installation of the application server per server. And as a result, this is a little bit the code that we wrote. Not exactly the first version, but still one of the first few versions. And as you can see, it's very straightforward. So first step, ensure that we have Java installed. And here the ensure that you can see in every single step is to remember the user that we are aiming to a state. We are not installing something. We are just ensuring that something is installed, for instance. Because obviously, if it's already installed, the step will be skipped. So all the tasks in Ansible are structured in the same way. They have a name, or they could have a name. I strongly suggest to add one, which is kind of the human description of what we are doing. Then they have the name of the module that we are going to use, YAM in the first case. And then it's going to take a bunch of parameters. As you might have guessed, this is YAML format. So today it's fairly common, I would say, thanks to Kubernetes and those other technologies. At the time, it was a little bit unusual, but still, I think, way more readable than JSON or other languages that are other formats that have not been designed for human readability. So as you can see, we have the name of the package here, Java 180 OpenJDK, and then the state, because we want it to be present. The other option would be absent, and then in that case, it would be uninstalled if present. And then we create the user, same thing, name, and then the description, ensure that the Glassfish user exists. And then we use this time the module called user. We provide the name of the user, Glassfish in our case, and then again, state present. And again, we install YAM unzip this time. So again, module YAM and same things as before. And then we ensure that we have a download copy of the installer. Now, in this case, we use the get URL module and the URL and the destination that we want the file to be present. Now, as you can imagine, if the file is already present, it will not be downloaded. If it's not present, it will be downloaded. So effectively, all those steps can be completely skipped after the first time they successfully run. And this is the rest of the script. So we ensure that we have the unarchived version of Pajara as well in /opt. And the remote SRC is because the SRC is already on the server, but obviously this is well documented in the documentation, what exactly every module options are and what are the possible parameters and so on. And then we basically do a chown, and that would be the Linux command to perform the same operation and basically recursively give to the Glassfish user and group permission on the ownership, of the /opt/Pajara41 folder. And then eventually we do copy the systemd unit to the proper folder. So as you can see, even if you are not a specialist of Ansible or have never seen maybe Ansible code before today, it's fairly straightforward to understand what are the steps. Now, obviously, assuming that you have enough knowledge about how to install or basic operations within a server. If you have never seen a server and you have no idea what is the owner of a file, obviously, and it does not really have too much, but probably you can still guess a little bit what is kind of happening behind the scenes. So a couple of considerations around this first example and things that we also have thought while doing it. The first one is, as we have seen, actually we did change the infrastructure. So we were not aiming to provide exactly the same environment that historically was created, but we aimed to create a new environment that was feature paired to the old one, but it was different. And the reason for this is that simpler is better. Every time you have one additional step, one additional software, one additional something, that something can break or will need time to get set it up, and then eventually time to be managed. So if a lot of times, and I have seen it many times after that, when you automate a process, you have first to understand the process, obviously. And when you map the process, maybe even more complex processes, like in big enterprises where everything is more like a process, you map a process from start to the end, and you discover that the whole process makes basically no sense, because the same person gets in and out in the process 50 times. And it's like, this makes no sense. So this automation, when you are automating the process, it's a great opportunity to rethink your process if obviously you have the allowance of actually doing it. So after that first process, we started to think, should we automate something else, and what exactly should be the next thing to be automated? And then the day after, a new person got hired. So we were thinking, okay, so what about this? Let's create users accounts for this new person. Is this a process good to be automated now, or should we wait for it? And then we thought, well, this is a boring process, because you basically have to create shells on 30, 40, 50, even more servers based on the kind of user. But still, it's a boring process. And effectively, it's a very simple process, because at the end of the day, user creation is not that hard today. And we got enough time to actually spend a little bit of it to exactly understand how we wanted to automate it and do it. So we started to think, what is the life cycle of a user? And this is, let's say, high level. Obviously, there are some things that could happen, like password change, which probably you should not really be using passwords for users, but keys or stuff like that. But still, there are obviously other cases as well. But there are two main processes for a user. The first one is the creation of the user. So you need to create it as a user on certain machines, add the user to a certain set of groups, and then add the SSH keys if you are using SSH keys, which is highly suggested. And then the other part and the other process is to delete the user. And when you delete the user, since we are actually ensuring with Ansible, due to the idempotency model, that the user is not allowed to log in anywhere or is not present anywhere, then we can think about, let's run it on every machine that we have, the delete user, because it makes more sense. I mean, if for some reason during his tenure or her tenure, they got to have access to additional machines that we were not knowing of, we still want to get rid of their accesses on those machines as well. So let's start from the creation of a user. We first of all create a user, so ensure that the user, and then obviously we will have a variable here, is present. We will use the user module in this case. Name is the name of the user. The shell bin bash, it's probably the most accepted shell by default for users. Then we can provide a set of groups and then a UID, because usually we want to have the same UID for every machine. In that system, there were some folders that got mounted and unmounted, and therefore it was better if a certain user had everywhere the same UID, and then obviously it stays present. And then same thing for SSH keys. We also have the module, Ansible module authorized key. We provide the user that will need to be accessible by that key, and then the key, which is a lookup of a file that is present on the machine called username.pub. And then we can simply execute it with this command, ansible-playbook-i inventory, which is the inventory of the machines, and then create user, and extra bars, we will have the name of the user, the groups that we want the user to be part of, wheel in this case, the UID, and then TGT host or target host, that, as you can see, is in the first line after host, because this script will be run only on host that will match that whatever string we put after that group in the inventory. So how is an inventory? How does it look like? This is how an inventory looks like. So we do basically have an INI file with a group. Web service is the first, JS is the second, and then a bunch of hosts. So in this case, we had only 4 target host web servers. So only the first 2 servers will have the user allowed, while the others will not. So the deletion is fairly straightforward, because in this case, we don't even need to remove SSH keys. We could, but we entrust the fact that if we delete a user, that user will not be able to log in anymore. So we simply have the name of the user and then state absent. And as you can see, the execution is even simpler than before. So some considerations again on this, but as we have seen, it's easy to create something that is what I would define as a distributed bash script, because you can create a bash script with 3 lines basically that does exactly the same, but on the local machine. If you want to execute it on 100 machines, then it becomes way more complex, because then bash is not structured to work across machines, but it's only structured to work within one machine. So a way that I see Ansible is like a decentralized or multi-machine bash scripting. And also, Ansible can improve the consistency of your environment, because if you start to, for instance, delete a user from every single machine, even the ones that they have never had access to, or at least not in theory, over time, you do have a more consistent environment. And then my suggestion is to automate step by step, but step by step in the good way, which is first you implement the first step, and then you use the first step. So it's a usable first step, and then you add one additional step that is still usable, and so on and so forth. Because if you try to automate everything and then roll it out, it will be a huge problem. So let's talk about a possible implementation of a better implementation of these user scripts that we have just seen. We could want to have a file, like YAML file, because obviously we are playing with YAML, so why not? That has a list of users, that those are users that, are all the users that should be there. So we could change slightly the previous code to actually use them. And as you can see, it's pretty much the same code. The only differences are that now it's the name of the variables are now, instead of just name, for instance, it's item.name, because we are going through a cycle, and that is due to the line with items that is repeated twice, 1 time per task. And that, gives us this thing of running through the whole list, and then for each item of that list. So for each user, we will be executing the same 2 tasks as before. And this time, obviously, the extra words that we will be passing will be a file with the at in front of it, so that Ansible knows that is actually a file to be read, is not like a string. So if you think about in a similar fashion, the life cycle of a server is not that different. I mean, it's different, but it's not way more complex, because you have the creation of the machine, let's say on AWS, but it could be anywhere. Update the OS, usually many people do it as soon as they get it, and then harden eventually the SSH configuration or the other configuration that you want to have, and then create the users, install the application that you want to use, correctly set up the load balancer and DNS, and basically have your server. And then over time, you might need to sometimes update your application or update users, or add, delete users. And then eventually, at the end of the life cycle of the server, you will be removing the machine from the load balancer DNS and then destroy the machine. So as you can see, the tasks are not that complex. Now, a lot of times we think about way more complex tasks than what they are really needed. So what I've seen is that starting from those kind of lists, when you do the automation, really helps, because you can focus on exactly what goes where. Then obviously this is not a working list, because your application will maybe have 8 different things to do in the harden the OS, or 5 in the install the application. But still, this is a first level list, and then you would have second level list, maybe tabulated list, so that effectively you have all the steps. And then you work on the list in like human readable form. When you are convinced that that list effectively works, what I do is simply add to the beginning of every line -name colon, and those become the starting point of my Ansible playbook. And then from there, I just add the Ansible code in between them to have then the first playbook. And then from there, obviously, you iterate and improve to ensure that you have a proper done playbook that works and everything else. So I would like to also suggest you to start from low-hanging fruit. So it does not make sense to try to automate the most complex process in your company or environment, whatever that is. Even if it's maybe the most interesting one to automate, that is not a good starting point, in my opinion. And I'm not talking only about Ansible. It does not really matter which automation system you use. Start with easy stuff. And then when you have confidence on the tool, how it operates, and your knowledge of it, then you can obviously go on more complex tasks. And then the important part is also to always aim for full automation, because unless you arrive to that full automation situation, you will always get processes that are not really optimized. I remember in a big customer, I saw the process for machine deployment that was 6 months long. So basically, from the time the developer requested a new machine to when that machine was actually delivered to the developer, that was a 6 month process, which makes no sense. I mean, you can go on AWS and in a few seconds have a machine. How is it possible that on a cloud, they had a 6 months lead time? And analyzing the process, we discovered the fact that the majority of time, the application, the process was stuck in waiting list, because it had to be approved by this board and that board, the other board, and the other board again. And every board had a 2-3 weeks wait list before the task could actually be considered by that specific board. So effectively, until we got around removing those steps, the build did not really change the build time. So there are a lot of processes that can be automated, and I think that it's very important and it's very easy when you start to think in this way around automation to see processes that can be automated everywhere. So an example is workstation management. I have done in some companies some Ansible playbooks to basically automate the creation, management, updates, and so on of hundreds of workstations. And that process was so nice and clean, in my view, that I started to have my own playbooks for my own machine, so that effectively every time I reinstalled the machine for some reason, I could recreate my perfect state, and I really enjoyed it. Other kinds of things that can be automated are like office automation. I've seen companies shutting down the office at the end of the day and restarting the office the day after with Ansible. That works. But also things that are not really IT related. So for instance, administrative processes where usually you have to download files, upload files, send files. Those kind of things can be very easily automated with Ansible. And then creation and deployment of lab environments. This is probably the one that I'm now using the most personally. I have some scripts to create a lab environment on AWS, on GCP, on other clouds as well. And then to create and destroy, every time I need a test environment, I just run one script, and I know that in less than 5 minutes, I will have my environment exactly as I need it. And then when I don't need the environment anymore, I just run one script and the whole environment disappears. So summing up, Ansible can give you a very simple way to automate processes in a lot of different situations, one of which is when multiple systems are involved. Second, always start from low-hanging fruit. It really helps. And then, if possible, rethink the whole process. And in this, think about like full company automation or full environment automation, because that is the situation where you really will have the majority of the benefits. And then remember that if we go on less technical automation, so for instance, administrative or tickets, that kind of things, you start to involve people. And when you start to involve people, the automation start to have impact on them, and they need to be on board with this as well. Also, I would like to close with this quote. This is from the Phoenix Project, which is a very nice book. I would really suggest having a look at it. And is around improvement, process improvement in this case. And the thing is, if you improve a process in its bottleneck, you will have a gain. Otherwise, you will only have done a pointless improvement. So be focused on when you improve a process to be sure that you are improving effectively the bottleneck and not a random place. Thank you. And if you have any question, I can reply to them, or you can also send them to me. I'm not seeing in the
That's
chat.
Brilliant, Fabio. Thank you. Does anybody have any questions for Fabio off the back of this talk?
I thought it was a very good talk. I thought it was very clear, great insight into it. I haven't actually used it myself, so it was very interesting. Thank you.
We've had a question come up in the chat. Has anybody tried using Ansible pull?
Yeah, so I've tried to use it in the sense that I've used it in test environments for test purposes. The Ansible pool model is not agentful, because that's not the point, but aims to that direction. At the beginning, my decision of agentless was more around complexity and security model. But over time, I've discovered that being agentless, it's a lot of time way better. Now, I do understand that there are cases like if you have 50,000 machines that you need to administer, there might be some limits around this kind of push model. So Ansible pool can be seen as a solution. I personally don't really like that approach, but I know that many people do, and that is the reason why there are such projects in the open source community.
Cool, thank you. Any other questions before I bring us to a close? I will take that as a no. So all that remains for me to say is thank you so much, Fabio, for coming and speaking to us. That was really interesting and really useful. We're getting lots of comments saying great stuff. Thank you so much. So yeah, I'm really pleased that that's been a great one for us as well. And thank you to all of you for coming and joining us this afternoon. I hope you enjoy the rest of your afternoon and have a great week. Take care.
Thank you. Take care.